Hello, 7th grade. I am going to go over the 4-3 homework that I actually assigned to you the last time we were together in the classroom. So hopefully you have it with you. If not, please find it. If you can't, take a second and redo it. I attached to this assignment a blank version of the homework. So if you do not have it with you, if you can't find it, go ahead and look at that blank sheet and do the homework before you watch me go over it, please. We're working on prime and composite numbers as well as prime factorization. So hopefully you have that with you. If not, pause this, take a minute, take a piece of loose leaf, and do the problems first, and then watch as I talk through them. So your homework was page 162, 14 to 42 even. And the first four here, we were just deciding if the numbers were prime or composite. Hopefully you remember that a prime number means that the only numbers that go into that number without a remainder are 1 and the number itself. To be a composite number, that means more than just 1 and the number itself go into it. So all we're doing for these four is deciding, are they prime or are they composite? 21, because numbers other than just 1 and 21 go into 21. For example, 3 and 7 go into 21 without a remainder. That means that 21 is, in fact, a composite number. Going down to 23. 23 has no other factors except 1 and 23. That means that 23 is a prime number. 17 is the same, only 1 and 17 go into 17 without a remainder. That makes it a prime number. 43. The only things that go into 43 without a remainder are 1 and 43. So again, this is a prime number. The next section of this homework had you write the prime factorization for each number. Number 22, they gave us 26. So remember, what we're doing here is looking for factors of 26. I don't mind if you start with anything that you know that goes into 26. So I'm going to do 2 times 13 would equal 26. As it happens, 2 and 13 are both prime numbers, which means we're done. So we can write our prime factorization and say 2 times 2 times 13. Don't love this for times, but it's what we're going to use for now. Next up, we have 66. So again, we need to think of two things that go into 66. So this time I'm going to choose 3 first. So 3 times 22 would be 66. And then we will need to further break down 22 because it is still a composite number. So if we come down here, then I can say, well, what goes into 22? So 2 times 11 would be 22. 2 and 11, as well as 3, are all prime numbers. So I can go ahead and say my prime factorization is 2 times 3 times 11. The next one up is number 26. The number for that is 56. So we need to think of things that go into 56. I'm going to start with 6 times 7, I think. You could also start with 2 on this one. Remember that doesn't matter what you're starting with as long as they both go into your number without a remainder. 7 is composite, or I'm sorry, 7 is prime, so that branch of our factor tree is done. 6 is composite, so we need to come down and break 6 down some more. Say 2 times 3 equals 6. Now these are both prime numbers, and we can go ahead and write our prime factorization, which would be 2 times 3 times 7. Now we have a big one. For number 28, we have 392. So I need to come up with some things that go into 392. I'm going to start with 2, because we know that 2 goes into it because the ones digit is an even number. 2 would go into 392. Let's see, 196 times. So 196, I know I can break that down because, again, our ones number is even. So I'm going to come down here and go ahead and say it, 2 has to go into it again. So I have 2 times, let's see, 98. And guess what? 98's even, which means 2 goes into it. So I can come down here and break 98 up. And again, we know that 2 goes into 98. And it goes in 49 times. Ew, what times itself equals 49? I think we just found the end of our prime factorization here. Let me scooch this over a little bit for you. As I'm sure you can guess, this is interesting trying to type these out for you guys. Alright, so we know that 7 times 7 is 49. So we can come on over here and say 7 and 7. And then those are all prime numbers. Remember on your papers, I asked that you guys circle all of your prime numbers, right? So you would have circles around anything that's prime on these lists. So we would circle in this one 2, 2, 2, 7, and 7. And then we can come down here and say our prime factorization is 2 times 2 times 2 times 7 times 7. Some of you, when we were last together, liked combining these with our friends, the exponents. So if you are going to do that, we would say 2 to the 3rd power times 7 to the 2nd power. I'm going to come in here and make these, oh, maybe not. I'm going to try to make those exponents for you. Keeps running away from me. Bear with me for a second here. I'm trying to find. Here we go. Superscript. So we can combine these into exponents and say, well, we have 3 2's. So that would be 2 to the power of 3. And we have 2 7's, so this one would be 7 to the power of 2. Remember that for our purposes in this class, this answer for your prime factorization is fine. We are saying that 2 times 2 times 2 times 7 times 7 equals 392. So we are looking to break down 392 in all of its factors, its prime factors. If you want to then represent our prime factorization using exponents, you're welcome to. We'll talk more about this next year, but for this year, this answer here is fine. Next up, we are going to be factoring some monomials. So I hope that you remember that monomials are our friends. They're fun to say, aren't they? So when we have a monomial, it essentially means we do not have any addition or subtraction. We can have numbers, we can have variables, we can have exponents because those mean we're multiplying the variables. This would mean c times c, and that's okay because we still don't have any addition or subtraction signs. This negative, even though it looks the same as a subtraction sign, is not a subtraction sign. It's just a negative in front of our 7. So this is also a monomial. When you're factoring monomials, what you need to consider is whether or not your number out in front of your variable, your coefficient, it's called, is a prime or a composite number. If your coefficient is a prime number, you're done. You don't need to do any work. You already have your factorization for your monomial. In this case, 14 is composite. So we're going to come down here and we're going to do a little factor tree, pretty short factor tree for 14, which is just 2 times 7. And now we have all prime numbers, and we can say that 2 times 2 times 7 times W is our prime factorization for 14W. Coming over to number 32, check this one out. -7 is already prime, so we're done. We don't even need these little factor tree guys. We're just going to say, hey, -7 times C times C is the prime factorization for this. Coming down, we have 20st and 28x squared y. Both of our coefficients here are composite, so we need to break those down. Here I'm going to say 2 times 10 is 20, and then I need to break 10 down further and say that 2 times 5 is 10. And now I have my prime factorization. The thing that I need you to remember here is don't forget your variables. Okay? You do not need to use them in your factor tree, but don't forget that they're there. Maybe circle them or put a star up there so that you don't forget to add them when you're done. Moving over, 28 we can say is divisible by 4, which would be 4 times 7. 4 is a composite number, so I need to break that down into 2 times 2. Once I do that, I have my prime factorization. So our prime factorization would be 2 times 2 times 7, and then do not forget those variables up there. We have x times x because it was x squared, and then times y. We have, I believe, 3 more problems here. Oh, look at number 38. That's just quick and easy. Number 38 is already a prime number in our coefficient. So all we need to do is break up our variables and say 13 times q times r is our prime factorization. Moving over here, we have 12 for our coefficient. Hang on, I think I wrote number... Somehow I wrote the wrong one for number 40. I noticed that because there was a minus sign in here, which shouldn't be there. So looking back in my book, I see that number 40 is actually negative 75 ab squared. So our coefficient here is negative 75. Remember that negative is just going to float out in front of our problem. So I'm going to include it in my first factor and say that that's going to be negative 5. Negative 5 goes into 75 13 times. No, that's not right, is it? About 15 times. 5 times 15. There we go, 75. 15 is still a composite number, so we're going to come down and break that up some more. 15, of course, is factors of 3 and 5. So we're going to plug those in. And finally, we're going to write out our prime factorization. So since you always write your prime factorization from smallest number to biggest number, I'm going to move my negative so that it's out in front of my 3 rather than my 5. And say negative 3 times 5 times 5 times a times b times b is our prime factorization for negative 75 ab squared. One more question down here. So is the value of n squared minus n plus 41 prime or composite if n equals 3? So we are going to think about what would n squared be if n is 3. So we could say 3 squared would be 9. So I now have 9 minus 3 plus 41. If I do 9 minus 3, it would be 6 plus 41. And that equals 47. 47 is in fact a prime number. So we believe have now completed the homework for section 4-3 prime factorization. I hope this was helpful for you. If you have any questions on this homework, please post them to the discussion board in your math class in Rediker. So you go to your student login on Rediker, scroll down to discussions, and you should see a discussion in the box on Rediker for your math class. So post any questions that you have there. I hope you guys are doing well, and I will make another video for you soon.